Hello everyone, today we're going to be solving question number 21 from the 2023 MathCount State Level Sprint Round. Question 21 reads, let x equal 352 ABC052, where A, B, and C represent digits that are not necessarily distinct. How many different ordered triples exist for which x is divisible by 44? Okay, so when it comes to divisibility rules, the first thing to always do is when you're asked to look at something divisible by, in this case, a composite number 44, break the composite number down into its prime parts. So 44 is equal to 2 squared times 11. So for a number to be divisible by 44, it needs to be divisible by 2 squared and by 11. Well, 2 squared, so for 2 to the n, the divisibility rule is that the last n digits of the number need to be a multiple of 2 to the n. And in this case, n is 2, so we're just looking at the last 2 digits. These need to be a multiple of 4, and then this number would be a multiple of 4. Since 52 over 4 is 13 and there's no remainder, this number is a multiple of 4. So now we just need to worry about it being a multiple of 11. Now, the divisibility rule for 11 is interesting. You start with taking the first digit, and you alternate your subtraction and addition. So 3 minus 5, because 5 is the second digit, plus 2 minus A plus B minus C plus 0 minus 5 plus 2. And this value needs to be a multiple of 11. So let's see, if you do 3 plus 2, it goes away with this 5. And now we're just left with 2 minus 5 is negative 3. So B minus 3 minus A minus C, this needs to be a multiple of 11. So you can write this as is congruent to 0 mod 11. All this says is that the remainder when divided by 11 of B minus 3 minus A minus C should be 0. To make this a little simpler, let's write this as B minus A minus C is congruent to, if we just add 3 to both sides, congruent to 3 mod 11. That means that B minus A minus C should have a remainder of 3 when divided by 11. So let's now do this systematically. Let's say, okay, what's the smallest B minus A minus C can be, and we can also consider what the largest it is. So you know the number, B minus A minus C, if you do some inspection, this cannot equal 3 plus 11, which is 14, because that requires that B be greater than 14, since A and C are also positive. So that's not possible, and then you could have B minus A minus C equals 3. That's possible. Suppose you had B equals 9 and A plus C somehow added up to 6. So now that's what we need to calculate, the number of possible ways this can happen. So we can have 3, and also the other ones to note are 3 minus 11, which is negative 8. For this to be negative 8, B needs to be, suppose B is 0, then A plus C can be 8. If B is 1, A plus C can be 9, and you can have a lot of possibilities. Okay. Minus 8, can it be minus 19? Well, for it to be minus 19, maximum you can have for A and C is 9, so this will be negative 18. If B is minimized, which would be 0, you get 0 minus 18, which is negative 18. So negative 19 is not possible. So that means the only possible ones are 3 and negative 8. Now we enumerate the possible triples. So remember, B minus A minus C, so that's B minus collectively A plus C, can either be 3 or it can be negative 8. So we'll list both of these, B, A plus C. So let's start with the smallest possible value of B. A plus C minimum has to be 0 plus 0, so that's 0. So B smallest is 3. Well, B is 3 in only one way, so we only have to worry about how many ways we can make A plus C equal to 0, and that happens in exactly one way, when A is 0 and C is 0. Well, when B is 4, A plus C can be 1, has to be 1, so A could be 1, C could be 0, or 0, A could be 0, C could be 1, so that's 2 possible ways. 5, this can have A plus C be 2, so AC can go from 2, 0 to 0, 2. When I say can go from, I mean it goes 2, 0. You can reduce A by 1 every time, and you get 0, 2 as the last one. So you can just count it by the difference of 2 minus 0 plus 1, as though you're just counting the number of possible counting the number of possible values of A in these triples. So 2 minus 0 plus 1, that's 3. So B can go up to 9. And then you have, this is 3, 4, 5, 6. This goes from 3, 0 to 0, 3, that's 4 ways. 4, 0 to 0, 4, that's 5 ways. 5, 0 to 0, 5, that's 6 ways. 6, 0 to 0, 6, that's 7 ways. So that means the total number of ways to get an ordered triple such that B minus A minus C is 3 is the sum of the first 7 numbers. That's 7 times 8 over 2, so that's 56 over 2, which is 28. Okay, now you want B minus A plus C to be -8, A plus C being collective in this case. So B starts off as 0, A plus C starts off at 8, and then you can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Correspondingly, A plus C goes up 1 each time. 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, starting from the top. This can go from 0, 8 to 8, 0, that's 9 ways. 0, 9 to 9, 0, 10 ways. Now this one, be careful, this one goes not from 0, 10 to 10, 0, but from 1, 9 to 9, 1, that happens in 9 ways. This from 2, 9 to 9, 2, that's in 8 ways. 3, 9 to 9, 3, that's in 7 ways. 4, 9 to 9, 4, that's in 6 ways. 5, 9 to 9, 5, that's in 5 ways. So maybe this is in 4 ways, 3 ways, 2 ways. And this sums up to be, well, this is the sum of the first 10 numbers essentially, so that's 55 minus 1, that's 54. 54 plus 9 is 63. So now that means 63 ordered triples for which x is divisible by 44, where B minus A minus C is -8, and 28 other ones, so 63 plus 28, that is 91. So 91 ordered triples exist that satisfy the condition in question.